Okay, so 5.2, we need a new tool in the toolbox because of all the things that we've learned this year or other years of our life, the amount of stuff that will help us do today's problems consists of nothing, absolutely not one thing. So there's a thing called the law of cosines. The law of cosines is going to work for any kind of triangle. The law of cosines could have worked on our other triangles other days as well, but we didn't need it. Because what stuff were we using that went out of style today?
Right triangle.
Right triangle stuff like Pythagorean Theorem. What else was right triangle based?
90-degree angles.
True. The main stuff we've learned that's new this year in your life, sine, cosine, tangent, those things. I shouldn't have said, I guess, that we have zero help from old days. Triangles still add up to 180 for the angles. That's still a thing. So you have one tool in your toolbox that helps you today. But law of cosines is this. It's c squared equals a squared plus b squared minus 2ab cosine c. The last c is a big capital C. What was that punctuation style about from yesterday? What were the big letters for?
Angles.
Angles. What were the little letters for? Sides. The two most important pieces of information to position in this are the little c, which is a side, compared to the big C, which is an angle. How is the side C and the angle C, how would you locate them in a picture? They're opposite. So in the picture, the side C that's going to go live here in the equation has to be opposite in the picture from the side, the angle C that we're going to put there. Does it matter who's A and who's B? No, because adding can happen in any order, and multiplying can happen in any order. So who you name A and who you name B does not matter at all. But it does matter that the side C that's opposite the angle C live on opposite ends of this picture. A brief aside before we use this. What does this remind you of from days gone by, but it's a more grown-up version? It reminds you of the Pythagorean Theorem. So I'm positive there's a question on the test where I'll ask you, what is the law of cosines equation? And you'd have to write this. I'm positive I follow that up with, what does that have to do with the Pythagorean Theorem? So you'd have to write me a sentence or two. The Pythagorean Theorem is only for right triangles. What does right triangle mean? Has a right angle, which means, what's a right angle mean?
90 degrees.
There's a 90-degree angle. So if we look to that and try to do the cosine of a 90, when in your past have you done cosine of 90?
Never.
You have.
Never mind.
Okay, you've done cosine of 90 semi-frequently on the chart. Cosine of 90 is part of the chart.
Good job.
What is cosine of 90 on the chart? It is 0. So if this part of the equation became 0, what would happen if you stuck a 0 here? Yeah, 0 times things makes 0. And what you're left with is
Pythagorean theorem.
Pythagorean theorem. The Pythagorean theorem is actually an offshoot of this. It's like a specialty version of this. This works in any triangle. The Pythagorean theorem, because it's 90 degrees based and cosine of 90 is 0, it eliminates like half the formula. The Pythagorean theorem is like half of the law of cosines, but only works for right triangles. So somehow you'd have to formulate that into a couple sentences that make human sense better than what I wrote on the board. I just wrote some sort of cheap, small ideas, but you'd want to mention for sure right triangles. You'd want to mention for sure 90 degrees. You'd want to mention for sure that the chart gives you a 0 that essentially wipes out the world. Question before we do a problem? So, what is the angle that matters to us the most for this world picture? 39. 39 is the only angle you have to choose from. So the only place for 39 to live is in the angle slot over here after the trig word cosine. Trig words always have angles after them. Who is opposite 39 in that picture? Yeah, let's call that x for now. So if 39 lives here, back here lives x, which should be
Squared.
squared. But that'd be your first move, is in the picture, find two things that are opposites, make sure they're both named. This had to be named x just to have a name, but with x opposite 39 in the picture, x goes opposite 39 in the formula. Then the other stuff, you just kind of throw it in there. This could be 5 squared is 25, or that could have been
49.
7 squared is 49. Those are reversible. It doesn't matter which one you stick with. 2 times 5 times 7. Okay, so 39. Question about how the numbers just got slotted. Your goal, as always, when it's algebra time, is that you like the x to be alone, and it almost is. Almost all the mess is out of your way. If you want to get the x completely alone, what do you have to do, opposite-wise? Root. All that stuff. And on the big calculator, you can do that in one big swoop. Just go root, punch that all in. We'll be hoping for something in the 4s. Something in the 4s, anybody? 4.43. That works for me. Tonight's homework is going to be a simpler version of where the chapter heads, and where you were yesterday, actually. Yesterday they gave you 3 pieces and they expected back
3 pieces.
3 pieces. In our future together, by the time we're taking a test, I'd give you 3 pieces and I'd want back on the test all 3 pieces. We don't have enough tools in the toolbox yet to do all that. Okay, they're going to just tonight ask you to do 1 more piece. I'll give you 3, they'll tell you which other one they want. Okay. Yes.
I didn't get the 4.43.
Root. Yeah, you want to do the root. You can now do the root of that answer that's shown.
That's not.
The root, and then do the answer button. So go yellow, and then the root button, and then yellow again, and then the bottom row, the answer button. There you go. Good. Good. Something there? Half the homework will be set up like that. They'll give you 2 sides, and they'll give you what's called an included angle. Like the angle where they're meeting, they'll give you the included angle for 2 sides. They'll want that 3rd side. So you'll do about half the homework just by square rooting a big, massive thing. Second choice, they'll go after an angle. So let's say that I specify, which one did I have on the paper? I'll go after that angle. There'll be some problems that they'll give you 3 of the sides, and they'll make you go get an angle. I usually do the angle first because there's only one of them. So there's sort of like fewer things to choose from. The angle would be x. And then based on x's experiences, should this be a 3 squared, 7 squared, or 9 squared?
9 squared.
A 9 squared. So x and 9 are opposites in the picture. So throw the x opposite the 9 in the problem. And then you have wiggle room as to who's who. This could either be 49 or 9. It doesn't matter. We're just going to square the other two numbers. Then who's going to live in here?
2 times 7 times 3.
2 times 7 times 3. Question about setup? This is going to take more algebra work. There's a lot of stuff in X's way right now. So a little bit of cleanup. What's something you can clean up?
49 plus 9.
49 and 9 is 58. Not too. We have 42. If we do these multiplications, that's 42. So we're looking at that. Sometimes people will start yelling at me right now to do 58 minus 42 and start yelling stuff about 16, and I always say no, 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 no. Why do I say no, 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 no?
Multiplying cosine x.
42 is multiplying cosine x. This is a trig version of unlike terms. Like in Algebra 1 days, you wouldn't try to combine those because they were unlike. This has an x and that doesn't. In trig days, these are unlike terms. You cannot combine those. So what you're thinking about is an Algebra 1 thing like this, what would you do then next?
Subtract 58.
Subtract the 58. That's exactly what we're going to do here is subtract the 58 to get a 23. Then divide not just by 42, negative 42. That fraction would be equal to cosine x. How do you make cosine x go away? Disappear. How do you make cosine disappear? Disappear. Inverse. Which is what? What's that? How are you going to do that? Yeah, the yellow button on the calculator. The opposite of cosine is inverse cosine. And when I say inverse cosine, I mean yellow button time on the machine. Which also shouldn't shock us, because our original project, we set out to get an angle. And we always get angles. Inverse. Inverse trig gets the angle. I'm hoping to be over 100 on this.
Yes. 123.203.
I agree. Question about that. I'll do one more of those. Just that was a little longer, and I have another thing to show you about it.
How do you get to the 123?
Second cosine, 23 divided by negative 42. Don't forget the negative on the 42.
Does that change things?
It does. Yep. If you forget the negative, I bet it threw you, what, like a 56?
Yeah, 56.
Yeah, so here's why. If you throw that a positive answer and ask it to do cosine for you, it will live in a positive quadrant. If you throw it a negative answer, this is a quadrant where cosine is negative, and that's the quadrant where we want to live. We needed to get something over 90. Something about that one? Same style, just a different thing is going to happen. So pick an angle, any angle, doesn't matter.
Top one.
Top one. So I call that x. Who should I start with then? 100. Since these are opposites, I'm going to get something that they go opposite ends of the picture. The 10 with the x. I'm going to go 10 squared. I'm going to throw an x down there. Or it could have been
4.
either way. 3, 2, and 7. then we'll go at it. A little bit of cleanup first. 53. Let's clean this up.
28.
28. Opposite pound.
Subtract the 53.
Subtract the 53 is 47.
Divide by -28.
Divide by -28. And then you would try to punch second cosine of that in your calculator says grrr. Something about an error probably.
It has to be under 1.
Yes. So we could have interpreted, there is no answer to this. We could have interpreted that in one of two locations. Late in the problem, we could have realized here that this can't be a thing. What was cosine when we invented cosine? We didn't invent cosine, but when cosine was first revealed to you, what was cosine? A over H. Why is it crazy to think about this being the A and this being an H?
Just the hypotenuse has to be the biggest.
Hypotenuse has to be the biggest thing. Sine and cosine can never go above 1. We did have a special case on the chart that they were 1. They could never go above 1. So if you ever have sine or cosine equaling a number that's bigger than 1, you could realize at this point that could never be a thing. That is not a choice. You could also have a geometry super flashback and realize just from looking at the picture that 2, 7, 10 could never be the size of a triangle. So anybody have an insight into that idea?
Two sides added together can't be smaller than a 3.
That is correct. There's a thing called the Triangle Inequality that tells you any two sides, if you add them, has to be bigger than the third side. So even if this were an 8, 2 and 8 could never make a triangle even with a 10 either. It has to be bigger, not even just equal. It has to be bigger than that. Like 2, 9, and 10 could work. But if you see two sides that are littler than the third, even when you put them together, it would be kind of like you're given a problem of there's a 10-foot chasm across the Grand Canyon, and they give you on this side a 2-foot stick, and on this side a 7-foot stick, and you try to build a bridge. What's going to happen to your bridge? You're going to fall in. You can't even reach each other, no matter how you do it. You could never build a bridge with a 2 and a 7. Could you build a bridge with a 2 and an 8? And some duct tape?
Yes.
I guess so, but that'd be tenuous at best. If they did a 2 and a 9, you could actually lean the things together, the boards, and fasten them up and have a legitimate bridge that made a triangle kind of shape going on it. But 2 of the sides have to add up to always beat the third. They will, I think, sprinkle some of these in the homework, maybe. I know for sure there's one of these on the test when we get there, where I'll sprinkle in something that's impossible. So you could either recognize instantly it's impossible and save yourself some time, or you could do the math for a while and realize later, oh, I didn't even have to do that one, that was impossible.
What would happen if it ended up being a 1 at the bottom?
That would be the 2 plus 8 makes exactly 10 bridge.
Okay.
It wouldn't be a triangle, it would just be like a totally
So
flat
if it was like a
thing.
Pythagorean triplet, then it would be impossible?
No, that would still work. One of those triplets would give you up an angle. Like if I throw you a 3, 4, 5, this will give you like a 36, a 53, and 90. Right triangles will still work on it. What would happen if I gave you like 3, 7, 10, you'd get back a 0, a 0, and a 180. Which sort of still adds to 180 like a triangle, but a triangle can't have two 0-degree angles. It basically just like imploded on itself.
So what would the answer be?
The answer would be that that's not a triangle.
Oh, okay.
Yeah, so if these add up to equal that, or if these add up to be smaller than that, it just doesn't have an answer. You could try to argue, I guess, that 0, 0, 180 still made a triangle, but I think that's a losing argument in my opinion. Homework, I think it's a 1 to 14.
Yes.
Yes. So we're up one page to 149. The first 6, they're giving you 2 sides, 1 angle. It'll be like the first one that we did together where we rooted the big giant thing. 7 to 14, they're giving you all 3 sides every time. And I can see for sure there are some that have no answers already.
Do you need us to draw a picture?
Not necessarily, but probably advisable. So if you're super good at visualizing stuff, it's not necessary. But I think for average advice to most people, the picture makes them like have a better handle on what they're doing. What you do need to do is write me out like a thing. That's it. See you later, Peyton.